Welcome back to another video where today I'm going to be talking about motor units. So I've been mentioning motor units, and you hear the term motor units in every single video relating to training and all that. But today I'm just going to explain what a motor unit is. So to start, a motor unit is basically a motor neuron and all the skeletal muscle that it innervates. And a motor neuron is basically muscle nerves that are responsible for muscular contractions and movement. But anyway, a motor unit basically being a motor neuron and all the skeletal muscle innervates. Basically, the way it works is motor units operate on a ratio where it's one motor unit, so singular unit, innervates multiple skeletal muscles. And this could be broken down into two groups. You have smaller ratios and bigger ratios. Smaller ratios are when there's one motor unit for a small amount of fibers, so somewhere in the tens to hundreds. And then you have larger ratios where it's still one motor unit. The amount of motor units doesn't change. It's always going to be one motor unit for hundreds to thousands of muscle fibers. And the difference is the small ratio is meant for smaller movements, like something like your posture, where your muscles have to constantly work to keep you up, and just small movements like blinking your eye, moving your finger, pointing, stuff like that. Small movements, it doesn't require a lot of power, not a lot of energy, and only a small amount of nerves, or I'm sorry, only a small amount of fibers are needed for those movements. Then you have your large ratio, which is broken down into your bigger, more explosive movements. So that's something when you're weightlifting, running, jumping, throwing. One motor unit is innervating, and innervating meaning nerve, is supplying the nerve supply to a bunch of different muscle fibers, usually in the thousands, and that's for your bigger muscles. So usually your skeletal muscle and stuff again like jumping, running, throwing, weightlifting, anything that involves large, forceful actions that you're purposely doing. So something like blinking and pointing, you're going to do that simultaneously, you're going to do that without thinking. But bigger movements, when it comes to weightlifting, for example, you're doing that voluntarily. You're purposely making your muscles move in specific ways and forcing them to contract. That's where the large ratios take place. And the two things that influence motor units are, like I said before, is motor unit recruitment and rate coding. So again, motor unit recruitment is the body's ability to recruit motor units. So you have low threshold and high threshold. Lower thresholds are going to be synchronized first because they don't require as much power. Higher threshold, they're going to be a little bit later in the lift. And as you get stronger and bigger, your body will be better at producing or recruiting higher threshold motor units. And rate coding is just simply the speed of contractions at which they fire. So as you get stronger again, your contraction speed will increase, which will let you put out more force. And then another thing about motor units is they fire on this principle called all or nothing. So the way it works is when you do muscular contractions, your motor neurons, your motor units, they have to fire, right? And by fire, that means they have to activate to lead to muscular contraction. They operate on this all or nothing principle where they either all activate or they don't. There's no half activation here. And one of the best ways I was taught this is through one of my professors. He said you're either pregnant or you're not. You're not half pregnant. So this applies to the same thing for contractions. Your muscles, the fibers are either going to activate and contract, or they're not going to activate at all. And all or nothing basically means once one is activated, they're fully activated, the contraction is going to happen no matter what, or they're not active at all. So that's one key principle for how motor units work, is when a contraction is bound to happen, all of them are going to fire and send out the signals no matter what. And if they're not going to contract, then they're not going to signal anything at all. There's no half signaling and then they go back down. Once they're active, they're going to signal a contraction, whether it be large, small, if you're lifting heavy weights, light weights. So if you're curling, for example, with just your arms like this, compared to curling with 30, 40-pound dumbbells, they're going to fire regardless.